Hello, welcome back. So for this session, we will discuss more about classes. Last sessions, we discussed chapter 2. So it's gave us some foundational idea about classes and objects. Okay, so today we will move to chapter 3. Chapter 3, it's about advanced class topics. Okay, so let's take a look. So you can also get our textbook at Candle Hunt publisher with this link. So in this chapter, so it's about advanced class concepts. Okay, so what we will start with is first discuss uh, passing reference as a method parameter. So basically here we are going to see how what will happen if we pass the parameter type is user-defined classes. So the parameter. Okay, so what does that mean? What will happen? And also, previously we discussed that Java is strictly pass by value. So in Java, there is no pass by reference. But we also saw that there are some effects that basically is pass by reference. Okay, so what does this mean? Okay, and then we will also learn two new keywords. So fine tune the class definition with the new keyword static and final. Okay. And because of the user-defined classes, so so far the example that we discussed is a simple example. So the instance variable type is either primitive data type or it's immutable string type. Okay. And it should also allow user-defined defined class type. Okay, so if we have instance variable that's user-defined class type, then what's going to be the relationship between the class that you define and the instance variable? Okay, so today we will learn the relationship, we call it aggregation relationship among classes. Okay. And in our previous discussion, we also discussed a couple of times about the difference between shallow copy and deep copy. And most of the discussion is about array, because array itself is also reference, okay? So there are some similarities, okay, regarding the reference, the heap memory. The array has some similarity as user-defined classes, okay? So we discussed the difference between shallow copy and the deep copy. And because we also learned array, okay, and user-defined class. So how do we process an array of objects? Okay, but this topic is not on the textbook, but you can find it on the supplemental textbook website. Okay, so regarding passing reference as method parameters, if you recall in our chapter 2, video 3, lecture 3, we already discussed in great details, okay? If you recall, regarding the person example, the first example about class, is it? We discussed this method. If you recall Java class example 1 person, in that example, we already discussed this method. So for this method, what it try to do is try to swap the two person, is it? And the two person basically, so person 1 and person 2 as a parameter, you try to swap, is it? So after you run the method, P1 and P2 supposed to be swapped using the temporary variable, is it? But we did see it wouldn't, okay, and we already explained in that lecture. And but later we discussed a second method in that example, swap person, okay? And in that case, it's not using just the class type for the parameter. In that case, we use array like P1 array, and then a second one like 1, and then P and P2 array. And for both of the array, then we saw that it did swapped. Okay, and we also explained in that lecture. So you can go back to review that part of lecture. So for the section, second section in this chapter, we also discussed pass by value, okay? And so pass by value, then how about the object? How in the method parameter? So the parameter is user defined class type. For example, of a person, okay. So then what will happen is we also discuss in great detail in the last lecture, okay? And we already know Java is strictly passed by value, okay? So a value is passed into a method, so the method receives and works with the copy of the variable's value, okay? So then based on this, because it's a value, you will not be able to change it. Okay, you will not be able to modify it. So, so the obvious thought will be like we are not be able to modify, but there is a difference. Okay, in Java, it's determined by the parameter if the parameter is primitive. Okay, because it's a primitive directly bound to stack along with its values. Okay. But for complex variables, such as class type or array, okay, then so their value, so what is the value here? It's a reference that point to some location on heap memory. So there is a difference. Okay. So here is the idea is you cannot modify. Then in this case, you cannot modify that point. That arrow you cannot modify, as that if you recall the diagram that we drew, but you can modify the value on the value that is stored on heap. Yeah. So then in this case, basically, it's not the strictly definition for pass by value. Okay, it's supposed to be pass by reference in C and C++ concept. Okay, so it depends. Okay. And for more detailed discussion, as well as the example about this topic, you can go back to watch the video 3 in chapter 2. Okay. Okay, so today we will learn a couple of new additional keyword used in class definition. Okay, the first is regarding the keyword static. So static can be used for both variable and method. Okay, method. So the concept for static is previously, when we discuss variable, we said instance variable and instance method. So clearly, before both of these two a word, we have that instance. So that means they belong to an instance of some class. Of a class. They belong to an instance, belong to an object. Okay. And if you have the keyword static ahead of that instance variable or instance method, then they don't belong to a single instance. Okay. So they belong to the entire class and they share across all objects of that class. Okay, so because of this property, this feature for the static variable, basically a common use for it is you can do some count, like keep track of how many objects created. Then you can keep using this, you can using this word static, okay, because then it belongs to the class and shared by all objects. Okay, so that's one of the common use. Okay, and we will see that in our second example regarding class. Okay, so just keep this in mind. And to access a static variable method, that's also different from instance variable and the method. Okay, so in this case, you don't need the object. You just need the name of the class. So name of the class. Okay. Okay, and the second keyword that's new for class definition is called final. Okay, so final, like in our second example, we for the M parent, the string type, we have a keyword ahead of it. We call it final. Okay, so what does that mean? That means for final variables, okay, they cannot be changed, okay, for any one instance, okay, but they can vary among. So for different instance, they can be different because they belong to instance, but you cannot change it. So once it's defined, like the M parent refer to this, then you cannot change it. You cannot change it to like doctor and doctors, something like that. No. So you cannot change. So final, it's kind of like in other programming language that we learn like a constant concept. Okay. So you cannot change it. Okay. But later on, we will see there are some subtle difference due to Java's uh, pass by value, okay, and those concept. Okay, and so for the final keyword, is it then we also have the difference like primitive data type or like immutable or mutable. So then what will be the cases? Will all be the same? So definitely no modification or there is some difference. Okay. So here it says final reference. So reference means like the mutable ones. Okay. But whenever it is declared, okay, for example, array or mutable class, then the reference arrow cannot be changed. So keep that in mind. So that point cannot be changed. So it cannot be reassigned to a different heap location. Yes, but the object on the heap can be modified. So this is a subtle difference, okay? So it's a kind of like, suppose we have that person, is it? So suppose you do declare like a private, like a private final, okay, person P constant, suppose you call something like this, is it? And uh, of course, it's needed to be initialized, okay, like person something. Okay, if you use the explain. So what will happen is, so here is a heap memory, is it? And here is a stack memory. Okay, so this P constant, then this is a block of memory that's created, so it will point to this block of memory. Okay, so suppose what you have, the name is default and age is 1, something like that. Okay, so for the final, what it means is it just means this pointer, it if you want to repoint it to a new location, that's not allowed. Okay, because it's final. Okay, you cannot. But this will be allowed. So the contents on the heap, you can change it the different to like hello. Yeah, this will be fine. Okay, so just be careful, okay, about uh, final, the constant concept here. Okay. And how do we initialize final reference type? Okay, we can initialize it. So if it is not a static, that you can just finalize it. So here is a declaration of the final. Then you can just use a block of code to do the initialization. Okay, you can also initialize it in a constructor. And if you have some variable inside the class, it's not just final, it's also static, then you can use a stack initializer block to initialize it. And we will see this in our example. So here is a summarization for the final reference variable. Okay, so it says for the final variable within class, so once initialized, you cannot be changed. So if it's a primitive, then the value. If it's a reference type, then the point cannot be changed. Okay. Initialization, so instance variable upon declaration, you can initialize. You can also using that initializer block or within the constructor. So three options that you can choose. Okay. For class variable, you can either do declaration or within the static initializer block. Okay. So within the method, so if the parameter is final, okay, then that it cannot be reassigned within the method body. Okay, so if the parameter also has a final keyword, then you cannot reassign it. Okay, so the next is a discussion about the relationship between classes. So in our second example regarding classes, we have two classes. We have outfit class, and we also have person class. So outfit, um, so in person class, we have an instance variable that's the type is outfit. So then what's the relationship between these two? So we call this two relationship aggregation relationship. So it's has a relationship. Okay, it has a relationship. So the idea is person has an outfit. Okay, so it's kind of outfits owned by person, is it? So in UML diagram, we draw UML diagram, you use a diamond to point to the owner. Okay. Okay, and the next concept is about shallow copy and the deep copy. Okay, so shallow copy basically is Also, if you recall previous in chapter 2, we also discussed its aliasing. Deep copy is clone. Okay. Uh, so for deep copy, the resulting object is a clone, and also make sure all members are clones also. So that's a real deep copy. Okay. So the resulting copy will be on a different heap location, and the member also on different heap location from the original. So be careful about this. Okay. So shallow copy can cause aliency issue, okay, for the resulting object. So it says for non-owner, like the outfit, then a shallow copy is just another variable name point to the original. So it's alias, point to the same heap location, etc. For owner object, like a person, it says, then a shallow copy could be just a simple alias or the clone of the container object, etc. But with aliens to the member. Okay, so the person may be a deep copy, but the outfit is still the alias shallow copy. So that's involved with shallow copy. And shallow copy, a lot of time, can cause some aliasing issue. Okay, so there is, if for your program application, you developer for security consideration, then you need to be careful about this. Okay, so because of shallow copy and deep copy for secure coding recommendation, if you recall for accessor, so get function, so get method, okay. Get method always return something, is it? So when you do return deep copy. Because if you return, if otherwise it will have that aliency issue. Issue, okay. And also sometimes you have method, the parameter as it takes some input object, okay, so reference. Then in this case, also make a deep copy of the method input parameter. Okay, do the deep copy. Otherwise, the same thing. What your method try to do probably is do some updating, is it for the object. Then you don't want the original be modified, but if you don't do deep copy, then it will cause the aliasing problem again. Okay. So these two are the recommendations regarding shallow copy and deep copy. Okay, so that's the end of discussion about the concept part for this chapter. So let's stop here and we will discuss the example in our next lecture.